It's not your design, okay? Not your code. You modify the code. The chances you are going to introduce new bug, it's 100%. 100%, okay? So regression test suite is actually the lifesaver. So how do you minimize regression suite? If you check out the documentation, if you have one, right? If not, basically you are essentially referring to the regression test suite, okay? So documentation may be incomplete, it may be faulty. Actually, all these test cases, that regression test case that runs, are actually correct specification, right? That's not correct specification, but the specification that really reflects reality, the real thing. Not all these documentation which can be at fault. I mean, no documentation can be incomplete. Okay? So your test suite actually, a lot of time, more important in documentation because your test suite will always go hand in hand with your code, but your documentation won't. How many of you think your requirement document is already out of date? Should be 100%. How about design document? 100%. How about test plan? If you raise your hand, then you are in trouble, right? Okay, I immediately give you a deduction on your grades, right? At this point, your test plan should actually reflect where your code is right now. Okay? Accept the fact your requirement document may be out of date. Accept the fact your design document may be out of date. That's okay, because that happens. But how do you utilize this documentation? The most important thing is actually your code repository. Okay? How do you use your code repository? You should check in your requirement document, your design document, all these documents whenever they are ready. However, if you made the modification after the documentation, you know the code you change may not reflect documentation anymore. If your documentation have been there for haven't changed, but you made multiple code change on the same features described by the document, you know your document is out of date. But at least you know where your document most likely to reflect on which version, right? That's actually give you a way to trace back and say, okay, in this particular version, my code and the requirement document is the most matched. Okay? After that, they diverged. At least that give you a checkpoint. Okay? So that's why at the very beginning I said, in our class, your repository, your GitHub repository is the key to success of your project and also future. That's why it's a critical software engineering tool. Every company here wants you to learn. First thing. So one thing to keep in mind, diligently checking your code, your documents, everything you have, test cases into your repository. Because that thing will faithfully give you a checkpoint of where you are and what files are related to each other. Okay? If you don't have a clear tag, at least you have a date, which is a consistent tag on all the files. Okay? Even if you don't know how to program in Java, I hope you do. You should know Git repository. With that, without using that, you're going to run into a lot of trouble in your developer life. Okay? GitHub, Git repository, and any other repository tools, they will faithfully record the correlations among all the files you have. But you got to check them in. If you leave files that not checking in, say you have a file which is sitting there, never checked in until the last moment, you lost all the history of modifications. All the history of all the modifications. Okay? If you have diligently checked them in, basically you can reconstruct all the file, even you lost one. Okay? So essentially you can follow the evolution tree of each file and know where you diverge between code and specifications. So GitHub really is your final straw before you sink. Really, that's your final straw to hold on. You should check in your code, check in your documentation, and your test cases, your regression test suite, on unit level, on system level. If you have to deduce information from the code itself, so in that case, I mean, if you have the code and regression test suite, to make sure that then you can say, okay, am I breaking the regression test suite? If I break it, clearly I have a problem, right? If I fix the bug without breaking any test cases, if my test cases provide a good coverage, then the more coverage my test case provide, the least likely I'm actually making a mistake. Okay, that's why we emphasize on coverage as well. You can check you can change your code. Then you can test the modification, run your regression, add the test case back into regression. Okay, if you add a new fix, okay, either you have to add a new test case, or you have to change your old test case. Okay, so once you test all these things, you need to basically create a new regression test suite, and your GitHub will help you do that as well by checkpointing. Okay, then document all the change, boom, check everything in. Then a year later, another programmer come here, he or she will have all the necessary things to move on. Okay, basic things. We're not talking about tricks. We're not talking about geniuses. We are basically talking about you follow very basic processes. Right? You have to test your unit, test your fix, test all the regression test suite, the tests in the test suite, regression suite, document the change, and use GitHub to mark it and check them in. Okay? You're done. Then you are going to save your own life. You're going to save somebody else's life for the future. That somebody could actually be you. Because if the programmer before you didn't follow this process, I mean, he already dig a big hole for you. You're going to bury yourself in the hole. You can only wish the guy before you, the lady before you is actually following the process. Otherwise, that's going to be a big hole. You have to somehow fill it out. Okay? This is while your manager and say, when can you fix the bug? Can you actually fix it tonight? We need to work overnight to get this fixed, and there's no documentation, no nothing, no GitHub. I mean, good luck with that, right? I think if you work in that mode, you are likely going to be burned out pretty quickly. Actually, in the medical profession, actually, maybe not a profession, but medical, they actually have a diagnosis for burnout. Okay? They actually have a diagnosis say, oh, this guy is work burnout. That's a medical diagnosis. Okay? If you don't have these, I mean, you and your fellow teammates will be burned out before any other team. Because you are basically redoing everything else, everything that other people should have done, rebuilding the wheels many times, trying to come up with the same design many times, trying to understand somebody else's code many times. I mean, if you are spending your energies and times on this kind of thing always, you can't really make much progress. But it all boils down to follow the most basic software engineering practice. What did we talk about here? Test-driven development, coming up with unit tests and system level tests, and use GitHub to check in your code, plus your test cases, plus any documentation you have. But minimum, you need to have your regression test suite. That's the minimum documentation you can provide. And that documentation is actually consistent with your code if you have done your regression test suite already correctly. Okay? I mean, all the documentation you have may be out of date, may be wrong, but as long as you pass all the regression test suite, that's passed. That's running. That's why my project manager actually can say, okay, which version you think you pass all the test suite and everything? I'm just going to get that version out, check out, and dump on a directory, and I compile everything. Everything should run. Why? We're checking on this. We are actually checking on this. Okay? Because this is something you got to do. We are here to see whether you're doing it or not. Make sense, guys? It's just not that, okay, you can come and tell me, look, my program runs, right? I demoed, I got 100 point scored on the checklist. Yeah? This may actually happen here when you say, okay, modification done, right? Everything fine. When you demo, everything looks beautiful, right? But you didn't run the test suite, the regression, and when I run it, crash and left and right, but somehow you got it right. That doesn't count. That doesn't count. If he or she has any suspicion, the project manager needs to go, dump your code, compile it, rerun all the test cases you have, and see if that actually works or not. Okay? Why? Exactly because if you're not even doing that, the programmer, developer who comes after you will suffer in a great way. Okay? That's the minimum we need to enforce. If not, it's not enforced in your team. You may have to think about, okay, is this the team I really want to work here, right? If there is no process, yeah, maybe it's easier for me to work in some sense, but you're going to pay for it eventually. Okay, here is the skill set you need for maintenance, basically diagnosis, testing, and documentation, basically what you have demonstrated in our class. Okay, requirement, design, coding, testing, and writing documentation. Okay, pretty much you have to do all these to graduate from my class. And you have to do all these in maintenance work. Basically, a software developer is doing maintenance most of the time. The only difference between development and maintenance probably is, in development, you sort of start with something, you're not starting with a working system. In maintenance, you're starting with a working system. That is, seems to me, that is the only choice, only difference, right? When you are doing development, you may have a halfway or not much finished system. You're building on that. In maintenance, you already have a version deployed. You are actually receiving feedback from your customers. I mean, that's all you have. That's the only difference you have, right? Have you delivered a version to the customer or not? If you have, hey, you're doing so-called maintenance work, but also you're doing development work. And in today's agile development of fast delivery and short increment, I mean, basically, you will become the maintenance is also your development process. Adaptive perfective maintenance. This is, you have to go through the requirement, specification, design, implementation flow, use existing product as starting point. Existing product means that you already delivered to your customer. Your customer has been using this and giving you feedback. And the defect reports, perfection adaptive reports, I mean, those things come from your customer. Indirectly, what you actually. Okay? So that is, you have to do all these things we have been studying in our early term, or early part of our term. Okay? So actually, nowadays, this is not true anymore. More likely, software developers are doing high-level design, detailed design, coding, testing, maintenance all together, right? So you basically, you also need to do testing and documentation. That's why software developer today, really, you have to participate in all the activities in software development, requirement, high-level design, detailed design, coding, testing, documentation. Then in maintenance, you do all these things again, 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 and again, until your software system is retired. Okay? Good software system never retires. Okay? I'm pretty sure there is still MS-DOS running on some computer today. Okay? Just good software system never retires. Only programmer retires, right? You probably will retire before your code retires, right? More likely that will be the case. For instance, I think in the IBM mainframe code, there are still some code that probably was done by programmer already passed away years before, right? So, but the code's still there. All right. So no form of maintenance task for unsupervised beginners and should be done by less skilled computer professionals. Basically, I mean, maintenance is where money pays, and also it's a very challenging job. A lot of time, I mean, to be honest, the only thing you got is that GitHub repository. Okay, you should be happy. All right. If you have access to the whole history of that GitHub, you should be like, oh, great. I got lucky. I got lucky. If you got a zipped file or a tar file, you know you are in deep water. Okay? If you got say, okay, here is a GitHub repository with all the history of this code from beginning all the way to the beginning of the code, you should really be happy. Okay? When you got an email with a tar file or zip file, you know you're in deep water. Really. You know you're going to have some quality time with your code, still not be able to get the job done. Okay? So when you have all these, if you have done as we allocated here, using GitHub repository, test-driven development, and checking all the documentation, okay, the next programmer comes after you will say thank you, and you actually left the code in some good. I mean, even if your code doesn't work, okay, it's actually better than a piece of junk that works with no documentation, no test cases, just in a tar file. Okay, that is essentially what we have been allocating here. You should be able to provide at least, at a minimum, this level of information for the next guy coming up. Because even if you are moving to a new job, you actually may be somebody, you may be after some, coming in the position after somebody, you'll be running the same situation. Okay? Checking all your documentation in time. Basically, I mean, today's repository is so powerful, daily check-in wouldn't be a problem. I mean, daily check-in already is not frequent enough, okay? Not frequent enough, daily check-in. I mean, whenever you make some modification, you can check in. You can check in. All these are useful information. People can choose to skip. But if they don't have this information, there's no way they can recover the information from thin air. Okay? If you check them in, they can say, this is a very verbose check-in person, but this is actually going to help them. Okay? All right, we have talked about all the tools I mentioned at the beginning of the term. You got able to do, and with that you are actually, programmer can go to work. Your Git repository, your IDE, your test environment, which essentially in our case is going to be just JUnit, right? Then you have a document writer, which no matter what is going to be Word, PowerPoint, what have you, right? So you're off going to next job, right? It's all come down to here. That's the minimum set of tools you need to carry out your job. Your Java IDE, your Git repository, your JUnit test environment, and your document writers. Okay? Once you get to team, you're going to get things like Slack channels for communications, Trello for project management. At this point, those are luxury you don't have to have, right? Right now, you just need your IDE, your Git repository, your JUnit test environment, and your document writer. Okay? With that, you are more than qualified to do your internship if you know how to use them in our project. Okay? If you say this is difficult, I'm not sure, right? So this is not that difficult. That's why it's very fundamental. Okay? Then you can take a piece of half a page worth of English specification, come up with a high-level design, detailed design, turn it into code, write test cases, get them tested out, deliver in the form of a complete Git repository, and pass that simple checklist of acceptance